Good morning students, we are back here again with one more new video. In the yesterday's lecture we had seen that how to express the concentration and what are the different methods of expressing the concentration. That is the percentage W by W method, percentage W by V method and the percentage V by V method, right? And we had also seen that what is the molarity, right, and how to calculate the molarity, right? So in today's period we'll be looking at what is the molality, what is the mole fraction, what is the saturated, unsaturated solutions and the supersaturated solutions, right? So my dear students, this is going to be a very useful lecture. So I request you, if you have not watched the earlier video, please go and watch that video and then come for this particular lecture, right? Because see, all the lectures are interlinked with each other, right? So that is why it is very important you start the lecture series right from the first video till the last video, right? So if you, in case if you have missed anything else, you can go back, rewind the video and watch it again, right? Okay, so in today's topic we will talk about the mole fraction, right? So yesterday only I told you that in your earlier classes, in your 8th, 9th, 10th standard, you all might have learned about the molarity, molality, then mole fraction, normality, everything you have learned it, right? So this is just a revision of this particular concept, right? So what is the mole fraction exactly? So in this case, what is the mole fraction? Mole fraction is the ratio of number of moles of solute and solvent, right? So my dear students, what is the mole fraction? Mole fraction is nothing but the ratio of number of moles of a solute and solvent is said to be the mole fraction. Now let's say that we have a solute, a solution containing a solute and solvent, right? Containing a solute and solvent. The mole fraction is represented by capital X. Remember, right? Mole fraction will be represented by the capital X. Now let's say that we have a solution. In this solution we have a solute and a solvent where the number of moles of solute is N1 and the number of moles of solvent is N2 and number of moles of solute is N1, number of moles of a solvent is N2, and we also have the X1 as the mole fraction of solute and X2 as the mole fraction of solvent, right? My dear students, are you understanding it? See, we have taken an example in which there is a one solution which contains the solute and the solvent, right? Where the number of moles of a solute is represented by N1, number of moles of a solvent is represented by N2, right? And X1 is represented as the mole fraction of the solute, X2 is represented as the mole fraction of the solvent, right? Now how we will represent the mole fraction? So let's see representation of the mole fraction, right? Therefore, mole fraction of solute, what is the mole fraction of solute? That will be represented by X1, right? So X1 is equals to N1 plus N2, right? Now what is the N1? N1 is nothing but the number of moles of solute. And what is N1 plus N2? N1 plus N2 is nothing but the total number of moles of solute plus solvent, right? Are you understanding, my dear students? See, what is N1? N1 is nothing but the number of moles of a solute. What is N1 plus N2? Total number of moles of a solute and solvent, right? So therefore x1 will be equals to n1 by n1 plus n2. Therefore, mole fraction of a solvent is represented as x2, right? Now x2 will be n2 n1 plus n2. Again, what is the n1? N1 is nothing but the number of moles of solute, right? N1 plus n2, total number of moles of a solute plus solvent. But here we have the n2, right? So what is the n2? Number of moles of a solvent, right? So n2 is equals to number of moles of solvent, and n1 plus n2, you all know, total number of moles of solute plus solvent, right? I hope, my dear students, that you have understood this, how to represent or how to write the mole fraction of a particular solute and solvent. Now when you add the both of them, now let's say we add the x1 plus x2, therefore x1 plus x2 is equals to n1 plus n2 plus n2 n1 plus n2, that will be equals to 1, right? So my dear students, this is how we represent the mole fraction. I hope that you have understood the concept of the mole fraction. So what is the mole fraction? Mole fraction is the ratio of a number of moles of a solute and solvent, right? Okay, my dear students, so let's move further. I hope that you have understood the concept of mole fraction. Okay, now second concept which is very, very important, that is molality, right? My dear students, what is the difference between molality and molarity? The basic difference between the molality and molarity is, in molarity there is a R and in molality there is a L. But let me tell you, this is a very, very basic difference. What is the exact difference? So let's see the definition of the molality. Molality is the total number of moles of solute dissolved in 1 kg of solvent. See, my dear students, this is the difference between the molarity and the molality. What was the definition for the molarity? The total number of moles of solute dissolved in 1 liter of solution, right? There it was a solution. Here it is a 1 kg of a solvent. So we can say that this is a solvent dependent quantity and that was the solution dependent quantity. Are you understanding, my dear students? In the last period we have seen all the solution dependent quantity, but this period we are seeing the solvent dependent quantity, in which the molality is nothing but the total number of moles of solute dissolved in 1 kg of a solvent, right? Now molality is represented by small m, right? So we have seen the molarity was represented by the capital M, molality is represented by the small m, right? So here next, molality is expressed in terms of molal solutions, right? Or you can say mole per kg, right? We have seen in the case of molarity how we express the molarity. We express the molarity in a mole per dm cube, right? So this is the representation. Now here in this case it will be mole per kg, right? I hope you have understood this, right? Or it is also sometimes said that a 1 molal solution, 2 molal solution, 3 molal solution, or you can also use the term molal, right? I hope that you have understood the difference. Okay, now what will be the formula? Let's write down the formula. Number of moles of solute divided by mass of solvent in kilogram right? Number of moles of solute divided by the mass of a solvent in kilograms. So my dear students, this is the formula. You have to note down the formula. Okay, now based on this, let's solve one problem, right? Let's say if 11.11 gram of urea is added to 100 gram of solution, then calculate the molarity of urea. Right, so my dear students, this is the question asked. If 11.11 gram of urea is added to 100 gram of solution, then calculate the molarity of the urea. Right, so how we will calculate? We are going to use this formula, but before using the formula, as I told you yesterday, that if you want to calculate the molarity, normality or molality, you should know the total number of moles. The concept of mole is very, very important, right? So what you need is the total number of moles present in the urea. How you will find the total number of moles? The total number of moles can be founded out by the weight of the given substance divided by the molecular weight. That means we also need the molecular weight of the urea, that is the molar mass. So step number 1, we will calculate the molar mass. Molar mass. Simultaneously you can note it down, molar mass of urea. Now what is the molecular formula of urea? NH2CO NH2, right? Now let's calculate the molar mass. How to calculate the molar mass you all know. In 11th standard I had taught you how to calculate it. See, we have to add all the atomic masses. When you add all these atomic masses, you will get the molar mass. So here in this case, nitrogen 14, hydrogen will be 2, hydrogen will be 1, 1 into 2 it will be 2, plus carbon will be 12, plus oxygen only 1, it will be 16, again nitrogen 14 plus hydrogen 2, right? It will be 60 gram per mole, right? So this is our calculated molecular molar mass of the urea now, right? Okay, now second step, mass of a solvent. Now what is the mass of a solvent given? It is the 100 gram, right? It is the 100 gram. But we need to convert this 100 gram into kg. See, what is our mass of a solvent in kilogram, right? Mass of a solvent in kilogram. So 100 gram converted into this will be 0.1 kg, right? I hope that you have understood how to convert it gram into a kilogram, right? Okay. Now here we had calculated the molar mass as well as we had calculated the mass of a solvent, that is the 0.1 kg. Okay, now let's calculate the moles, total number of moles of urea. Moles of urea or total number of moles formula is weight of a substance, that is the given substance, divided by the molecular weight. So what is the given weight? 11.11 gram was the given weight, divided by molecular weight 60 gram, right? So in this case it will be something 0.1852 molar, right? So here we got the moles of urea. Now what is the urea in this case? Urea is nothing but the solute particle. So it will be the total number of moles of solute. Are you understanding? Moles of urea is nothing but the moles of solute, right? Okay. Now let's put the formula and let's calculate the total number of moles. Now here in this case, what will be the formula? Formula will be number of moles of solute divided by mass of a solvent in kg, right? So M is equals to number of moles of solute, that is equals to 0.1852 divided by mass of a solvent in kg, that will be 0.1. Mass will be something 1.85 mole, 852 mole per kg. So this is the answer of a molality, right? I hope that you might have understood this problem. You have to note down this problem. It is a very, very important problem. Such type of a problem can be asked in the exam for 2 marks, right? Okay. Now let's move further. Now let's understand what is the normality. Right? This is also a very, very important term. What is the normality? Normality is the gram equivalent weight of a solute dissolved in the 1 liter of solution, right? So what is the normality? See, try to understand, this is the gram equivalent weight, right? It is not the number of moles, it is the gram equivalent weight of a solute dissolved in the 1 liter of solution. Molarity के केस में क्या था? The total number of moles of a solute dissolved in per liter of solution. There it was a mole. Here it is the number of gram equivalent of weight, right? Dissolved in the per liter of solution, right? Okay, now here in this case, normality is represented by capital N, right? It is represented as the capital N, and it is expressed as equivalent per equivalent, right? Per equivalent liter, and the formula for this is number of gram equivalent weight divided by volume of solution in 1 liter, right? So this is the formula for the calculation of the normality. Number of a gram equivalent weight divided by the volume of a solution in a liter. Okay, now what is the gram equivalent weight? Gram equivalent weight is nothing but the weight of a solute divided by the equivalent mass. Weight of a solute divided by the equivalent mass. That is the gram equivalent weight. Right? So you also note down this formula. You should know that what is exactly the gram equivalent weight. Gram equivalent weight is equals to weight of a solute divided by the equivalent mass, right? I hope that you might have understood the concept of normality. Okay, now let's come to the last part of this chapter, of this particular session actually. That is the saturated, unsaturated and supersaturated solution, right? Saturated, unsaturated and supersaturated solutions, right? So let's understand this. What is the saturated, unsaturated and supersaturated solution? For this we will take one example. We'll understand with the help of an example. Let's say that we have one beaker. We have taken 3 beakers. Right? We have taken 3 beakers, and this all the 3 beakers we are going to fill this with the we will fill all the 3 beakers with 20 ml of water. Now what is the water here? Water is acting as the solvent. 20 ml of water, right? In all the cases, right? So I have taken the water as the particular solvent in all the 3 cases. Now to this particular water solvent we are supposed to add the solute, right? Now what will be the solute? Let's say we will add a sugar as the solute. to all the three beakers, and then we will understand what is saturated, unsaturated and supersaturated, right? Okay, let's take the example number 1. This is stage number 1. So what happens in this stage? If I add a 10 gram of a solute, that means 10 gram of sugar to this 20 ml of water, and I will start stirring, what will happen after some time? All the crystals of the sugar will easily get dissolved into this particular 20 ml of water, right? I hope that you are understanding it. So here we can say that it is less amount of solute added to the solvent, right? It is the less amount of a solute added to the solvent. That means easily 10 gram of a sugar can easily get dissolved in 20 ml of water, right? There will be no formation of a crystals at the bottom in this case. Okay, now I hope that this is very clear. Now such type of a solutions where the required amount of a solute is a less, then that kind of a solutions are said to be unsaturated solutions. What are unsaturated solution? Whenever the amount of a solute which is required is very less, that particular solutions are said to be the unsaturated solution. Now let's come to the case number 2. Now what happens in this case? Now let's say that if I add 15 gram of sugar, right? Now see, I have increased the quantity of a sugar. Now what will happen? See, 10 gram was easily dissolving, but what happened to a 15 gram? 15 gram also got dissolved totally, but here the stage has come after addition of a 15 gram that no further addition of the sugar can be done. And if we add the further sugar, the sugar will start crystallizing it, right? So this is said, it is the required amount of, solute added to solvent to attain equilibrium, right? So here we can say that it has attained the equilibrium. Now no further addition will take place. That means if you add the further addition of a sugar, it will start crystallizing now, right? So such kind of a solutions are called as the saturated solutions, right? Saturated solutions मतलब क्या होता है कि अभी एक